Wow, what a beautiful day in the park. Such a nice day after the Thanksgiving holiday. Oh, look at that beautiful tree. I'll finally get to take some time off. Thank goodness. Oh, hey, Dr. Romano. What are you doing here? You want to go for a walk with me in the park? And look at some colors, leaves of the tree?
No, but I would like to do a chemistry problem, so come along. Let's have a look.
Okay, Dr. Romano, but that's not what I had in mind today.
Well, indolence never leads to success, my friend, so why don't we get cracking here? The first thing I want to do is to do a problem on Raoult's law. This is going to test one of the colligative properties. Now, colligative property that deals with vapor pressure says that when you put in a solute in a solution, what's going to happen is that the vapor pressure is going to be lowered. Now, in this example, at 30 degrees Celsius, the vapor pressure of water is 31.82 torr. Now, what we're going to do is we're going to dissolve 218 grams of glucose, which is a non-volatile solute, in 460 milliliters of water at 30 Celsius. And I want to know, what is the vapor pressure lowering? The first thing we have to do is to have a ballpark idea what's going to happen is the vapor pressure is going to lower it. So if you're starting at 3182, the vapor pressure is going to go down. So even if you knew nothing and you had to guess maybe 31.10, 30.90, something like that, this number has got to drop. So no matter what, we got to get an answer in which that number drops, and then we're going to look at the difference. Now, the first thing we're going to do is I'm going to take 460 mLs of water and realize that since the density of water is equal to 1, if you multiply the density by the volume, that will give you the grams. But you don't need to do all that bullshit for the simple reason is the milliliters of water and the grams of water is the same thing since the density is 1. So 460 milliliters of water is 460 grams of water. And what I did here is I converted the grams of water into moles of water by dividing by the weight. The DAT exam will give you nicer numbers, but for argument's sake, let's pretend these numbers are really nice, and when we divided it out, you got 25.6 moles of water. Likewise, 218 grams of water, let's convert that to moles. I look up the weight of C6H12O6, which is the molecular formula of glucose, and it's 180. When I divide 218 by 180, I get 1.21. Let's add up the total moles while we're at it. So 25.6 moles of water and 1.21 moles of sugar, glucose, gives me 26.81 moles total. The next thing I do is I put up what we call Raoult's law that says P equals P prime times X of solvent. The X of the solvent is the mole fraction. P prime is the vapor pressure of the pure solvent. Here it was 31.82, that was given. The P on the left side is the partial pressure of the solvent over the solution. All right, plug and chug. P prime is 3182. The X of the solvent is the moles of solvent, which is the water, 25.6, over the total, 2681. And when you did it, you came up with an answer of 30.38. Makes sense, the number has dropped. But we want the vapor pressure lowering, so that change in pressure will be the 3182 minus the 30.38. The difference is the lowering, which is 1.44 torr. And as you can see, the vapor pressure has changed by this amount. I hope this helps on a really good problem that you're likely to see on the actual DAT exam. All right, good day to you.
Dr. Romano, I saw some grills here. Maybe I'm going to grill up a little corn and stuff.
All right,
you want any?
Good for you. Good day to you. Bye-bye.
Coffee?
Good day to you.
Good day to you, sir. I'm off to have fun. Wow. What's up here? Look at the squirrels. Good day to you, sir.